Now let us see what is Levenshtein distance. Now Levenshtein distance is an algorithm which was developed by Levenshtein. It's a very common algorithm, and it helps me to understand, but with the help of minimum number of edits that will be required. Now edits can be insertion, deletion or substitution to change one word to another word. So consider, so so here in Levenshtein distance, I will consider what is the length of the word, and then what is the Levenshtein distance between the two. Let us consider the two words king and kind. Okay. Now under king and kind, here between these three there is no Levenshtein distance. Now the the fourth one, here there is one substitution that is required, and so the Levenshtein distance between the two is 1. Now let us consider the Manhattan distance. Manhattan distance is very much similar to Euclidean distance, just that the Manhattan distance captures the sum of the absolute difference that is there between the coordinates of the point. Manhattan distance is taken from the city of Manhattan, where everything was like grid-like streets, and so the two points can be, the distance between the 2 points can be calculated by the sum of their absolute distance. So one example of this is x1 minus x2 plus y1 minus y2. So if I take the square of this and the root of this, then it becomes Euclidean distance. Otherwise it is the simple Manhattan distance. So if I consider 2 points, here 3, the absolute difference will be 3 plus 5 minus 1, it is 4. So the Manhattan distance is basically a 7. If I have to take the Euclidean distance, it will be 3 square 9 plus 4 square 16, 9 plus 16 25, root of 25 will be 5. So the Euclidean distance is going to give me 5 in this case, and the Manhattan distance is going to be a 7. It's just by calculating the absolute differences that are there. So Manhattan's distance is like measuring the path along the grid lines, whereas the Euclidean distance checks for the straight line distance between the 2 points. So this is basically the Manhattan distance, considering like in a grid-like format. This is the Euclidean distance from point to the point, and this is the Minkowski distance. The Minkowski distance, if I consider P is equal to 1, then it becomes the Minkowski distance generally refers to what power and what root are we taking. So Minkowski distance, if P is equal to 1, then it gives me the Manhattan distance, and if P is equal to 2, then it becomes the Euclidean distance. It just indicates if I take mod of x1 minus that is mod of x1 minus x2 plus mod of y1 minus y2, then it becomes Manhattan distance. If I take root of x1 minus x2 the whole square plus y1 minus y2 the whole square, then it becomes Euclidean. So generally the definition of Minkowski distance is x1 minus x2, the absolute value of x1 minus x2 to the power p plus y1 minus y2 to the power p, the whole to the power 1 by p. So if I include p as 1, then that is without any calculation, then it becomes Manhattan distance. If it is 2, then it is square root and the square root and the square, and then it becomes this Euclidean distance. So this is the Euclidean distance and this is the Manhattan distance, which is considered in a grid-like format. So if Manhattan distance makes sense if I am looking for grid-like paths like city blocks, circuit board layouts, where the diagonal movement is not allowed. Euclidean distance is more like physical distances. So let's say if I'm looking for Google Maps, then I would consider something like a Manhattan distance. But let's say if I'm looking for drones, then I would consider Euclidean distance. So Manhattan distance get used for pathfinding algorithms. Like for example, just now we discussed Google Maps. Then it can also be used for clustering data, like where the lower sensitivity is needed. Then it can also be used in image recognition, can be used for outlier detection also, because it is less extreme sensitive to extreme values. It can also be used for GIS applications like grid-like street networks and these features.